This is Mrs. Kraft, and today you're going to take notes on particles. Specifically, you're going to take notes on the differences between atoms and molecules. Our notes today are going to be mostly visual. We're looking for a general difference between atoms and molecules. If you remember learning about this in 4th or 5th grade, you probably heard the terms proton, neutron, and electron. We're not really going there today. This is what your worksheet looks like. We do need to glue it in, but you can decide to write on it first or glue it in and then write on it. You will need several colors in order to do this notes effectively. You do not have to use the same colors as I am using, okay? So they can be different colors, but I would like you to make sure that your hydrogen, carbon, and oxygen are 3 different colors. Starting at the top of our worksheet, we have particles, which is our overarching heading, and it encompasses both things that we're going to talk about today. On the left side, we have atoms. You may remember that cells are the building block of life. Atoms are basically the building blocks of matter, and matter is anything that has mass and takes up shape. Starting with the top one, we have hydrogen, and in your box, you're going to write an H. H is the atomic symbol for hydrogen. So if we look at the periodic table, that's what we're going to look for in order to find it. And if you look, it's actually the top one on the left side. It is the first element. And it is so because it is the small element. When we draw this, you want to make sure this is a relatively small circle. So we have a small hydrogen. It's colored in gray here, but I would normally draw it white. So if I was drawing this on my notes in real life, I would just outline it and draw an H on the inside and leave everything else white. Now I've chosen white for hydrogen here because of convention. So anytime you look at textbooks as you continue on in your chemistry career, you're probably going to see hydrogen represented as a white sphere. So I've chosen colors that you're just likely to see as you continue on. Carbon is the next one we're working on, and it has an atomic number of 6. So if you find it on the periodic table, you're looking for the letter C, and it is on the right-hand side, but still near the top. Carbon is a little bit bigger than hydrogen, so I'm drawing the circle a little bit bigger. I've chosen black this time, just again for the same reason. It's likely to show up in textbooks as a black sphere. And our last one for this side is oxygen. Oxygen has an atomic number of 8. So if you look on the periodic table and find the O, it's actually just 2 doors down from carbon. Because we're still continuing on and we're at a higher number, oxygen is bigger than carbon and it is bigger than hydrogen. So in my chart, that's the biggest one. And I have chosen red to show it for this. Going back up to the right-hand side of our worksheet, we've already done atoms, so now it's time to talk about molecules. Molecules here, I have 3 examples. One is water, which is noted as H2O. That means that there are 2 H's, 2 hydrogens, and 1 oxygen. Many of you remember that H2O looks like a little Mickey Mouse head. Here, the colors are similar. So I have red for my oxygen, and then I have 2 white spheres. They look kind of grayish here to represent my hydrogens. So every time I have a molecule of water, it looks like this. If I have a whole glass of water, I have hundreds or thousands or millions of these exact same molecule. They're always paired up the same way with 1 oxygen and 2 hydrogens. Underneath that, we have carbon dioxide. And carbon dioxide is known as CO2. So again, this time if we look at where the 2 is in the first one, we had H2, which means that there were 2 H's. This time the 2 follows the O, so there are 2 O's. So we have 1 carbon, 2 oxygens for every 1 molecule of carbon dioxide. And here's what it looks like. So I have my carbon in the middle, and I have my 2 oxygens on the outside. We next are going to look at sodium chloride, which is a different kind of molecule. So these 2 are both covalent molecules, and that just means that they share electrons in a certain way. The next molecule shares them a little differently, so it's actually where one will give an electron and one will take an electron. We don't really need to know the mechanics of that here, we just need to know that these are two elements that are on opposite sides of the periodic table, so they haven't been brought up yet before, right? We're not looking at hydrogen, carbon, or oxygen. Sodium chloride, or table salt, is made up of NaCl, which is sodium and chlorine. Now, if we just looked at what we have above, we could assume that for every sodium chloride molecule, we'd have one copy of Na and one copy of Cl, because there's no little numbers here. But because it's a different type of molecule, it's ionic, it actually shows up as a crystal structure. So you're going to take two colors and try to alternate them in a way that looks like a cube. Okay, so that's what gives salt its shape. If you look really closely at the crystals, this is what's happening on the molecule level. Now, if we look at the worksheet in general, you should notice some differences here. On the atom side, these are singular circles, right? One sphere for each atom. And on the molecules, both of these examples are three, right? 1, 2, 3. 1, 2, 3. Three things together makes a molecule, but really a molecule is two or more things. So it could just be two things together and that's fine. Or you could have a more complicated structure like this sodium chloride crystal where the things kind of interlace and they go in a very specific pattern to make crystals. Before we finish this, I really wanted to point out a couple of things, just because if you're ready to go to more advanced chemistry, I want you to be aware of it. Hydrogen and oxygen, while I put them on the left side, I chose them because of these molecules that we were talking about. In reality, hydrogen and oxygen are special. They're called diatomic elements or diatomic molecules. So just floating around, there's not really ever going to be a H by itself. Because it's diatomic, that Di prefix means two. And so what happens is that it just hangs out with another copy of itself. So instead of being an H floating around by itself, it actually becomes an H2. And this one the same thing. Instead of being an O by itself, it becomes an O2. And it looks more like this. So realistically, those could be in the molecule side as well. But for today's purposes, I wanted you to see that atoms are a single thing. So I included them on this side and only drew one circle of each one. All right. Hopefully your notes are finished now. Go back and pause if you need to. Have a good day.